Okay, students, on this clip we're going to be going over an example where we're going to be looking for the derivative of a function, and the process will involve the use of the product and chain rules. All right. Okay, so let's go over the two rules real quick first before we apply them. So the product rule is applicable to functions that involve the product of two functions. So let's say we have two functions f times g. Then the derivative of that function f times g prime is going to be g f prime plus fg prime. All right. And in most textbooks, it's represented using u and v. So if you have two functions u and v, prime is basically vu prime plus uv prime. All right. So this is what the product rule is. Well, how about the chain rule? Chain rule is a little bit more complicated. It involves a function that is a composition of two functions, okay? So let's say we have f of g of x as a function, and if you want to find the derivative of that, all you simply do is you find the derivative of the outer function holding the inner fix, f prime of g of x, and then you multiply it by the derivative of the inner function, okay? So if you have two functions you nested to each other, you do it like this. If it's three functions nested, you keep on going three times, okay? So that's basically the chain rule for you. All right, so now let's go ahead and consider the problem. Problem one, find um, f prime of x, where f of x is equal to 3x squared times the square root of 3 minus x. I'm sorry, 3x minus 2. Okay? All right, so I can clearly see that I have to use the product rule here because we have a function being multiplied by another function. And it's obvious also that I have to use a chain rule because the second function is a composition of two functions. Okay? It is a composition of a radical function on the outside with a linear function on the inside. All right? Okay, so what we're going to do first is I want to rewrite this function so it's easy to differentiate. So let's rewrite this. So if I rewrite it, I'm going to rewrite f of x as 3x squared times 3x minus 2 raised to the 1 half. You see, expressing this radical function as a power makes it easy for me to make use of the power rule when differentiating. All right. So if you take a look at this setup, you can see that um, this first function right here, this quadratic function is u, and then this composite function, which is a composition of a radical and a linear function, is v. All right. So now let's recall the formula. What is uv prime? What is the derivative of a product of two functions, where it is v, the second function, times the derivative of the first, plus the first function times the derivative of the second. All right. You can switch the order of these two terms. Remember, addition commutes, so it doesn't really matter. The order doesn't really matter. All right. Okay, so let's go ahead and apply this formula. I'm going to do it step by step individually before I put them together. Okay, so u is 3x squared. So using the power rule, let's look for u prime. Let's look for u prime. U prime is going to be 6x. Okay, and then v is the composite function 3x minus 2 raised to the 1 half. So let's look for v prime. So v prime is going to be, using the power rule for the outer function, 1 half times 3x minus 2. 1 half minus 1 is negative 1 half. We just differentiated the outer function of f prime of x. Now let's differentiate the inner function, which is a linear function 3x minus 2. So the derivative of 3x minus 2 is simply 3. All right. So let's rewrite v prime. We can rewrite this as, this is 3 over 1. So 3 goes in the numerator over 2 times the square root of 3x minus 2. Okay. So we now have everything that we need. Now f prime of x is going to be, remember we said vu prime, so all right, this has v is 3x minus 2 to the 1 half. Yes, v u prime is 6x plus uv prime, right? So u is 3x squared, and then v prime is 3 over 2 root 3x minus 2. Okay? Now you might want to think of simplifying this radical, rationalizing the denominator here, but refrain from doing that until you get to the end, okay? So just in case, it might be easier to combine fractions in this formulation. So let's rewrite this, simplify it a little bit more. So I'm going to write this as 6x times the square root of 3x minus 2 plus, this becomes 9x squared, multiply the numerators, imagine that there's 1 here, over 2 times the square root of 3x minus 2. Alright, now we have two fractions. One fraction, and this is not a fraction right here. So I need to make this into a fraction, so divide it by 1. Now I need to find the LCD here. Okay, LCD of these two fractions. So to do that, the LCD is going to be 2 times the square root of 3x minus 2, because this is 1 right here. So what I'll do is, to make them have the same common denominator, I'm going to multiply the bottom here by 2 root 3x minus 2. And then on the top, I'm going to multiply by the same thing, 2 times root 3x minus 2, like that. Alright? Okay, now in the numerator, I'll multiply these 2 and 6x are not radicals, so multiply them together, I have 12x. And then if I multiply root 3x minus 2 and root 3x minus 2, I'll have root 3x minus 2 squared. Okay? Plus 9x. Now the two denominators are identical. So the two denominators are not identical, I can just combine them into 1. So it's going to be 2 root 3x minus 2. Alright? Okay, now let's simplify further. The square roots, this square and this square root cancels out. Okay? And if they cancel out, we're going to have 12x multiplied by 3x minus 2 plus 9x. And that whole thing, we're going to divide by 2 root 3x minus 2. Okay? Alright, now we can distribute this 12x to these two terms in the parentheses right here. Distribute that into that and that, so that's going to yield 36x squared minus 24x plus 9x, and that whole thing divided by 2 root 3x minus 2, so divided by 2 root 3x minus 2. Alright, now let's combine like terms in the numerator. If I combine like terms in the numerator, I'll have, let's see. Looks like I made a mistake somewhere here. Yeah. This is a square, this is supposed to be a square, this is supposed to be a square, and that's supposed to be a square. Okay, so there you have it. Okay, now I can combine 36x squared, 9x squared together, so we have the same power. It becomes 45x squared minus 24x, and that whole story divided by 2 divided by 2 root 3x minus 2. Okay? Alright, and that's basically your final result. Okay? Now, some books might require you to simplify, or some teachers might want you to simplify this because you have a radical on the bottom. So in order for you to get that, you can just multiply the numerator and the denominator by root 3x minus 2 to rationalize the denominator. Alright, and if you do that, you're basically going to have 45x squared minus 24x. Alright, and the numerator divided by, well, since I multiply top and bottom by just a radical component in the denominator, I'm going to have this whole thing multiplied by the square root of 3x minus 2. And then in the denominator, If I multiply by root 3x minus 2, the square and square root cancels out. So I'll have in 2 times 3x minus 2. And you can distribute these 2 further, it becomes 6x minus 4. Alright, so this is just another way of expressing the same answer. These two answers are correct for finding the derivative. Alright, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here so you can get updates to other cool math calculus clips such as this. And please post a comment to let me know what you think about this presentation. More clips can be found on mathgotserved.com. Thanks again and have a wonderful day.